Hi students, now we are going to see some sample problems in reciprocating air compressors. First, let us see the given data in the first problem. This problem is regarding single stage double acting compressor. We know in the case of double acting compressor, number of working strokes is equal to 2 times of the speed of the compressor, and the free air delivered given in the problem is 14 meter cube per minute, and here the clearance volume is considered, and the suction pressure, suction temperatures are given, and the delivery pressure is given, and the clearance volume is equal to 5 percentage of stroke volume, and we know Vc by Vs is nothing but 5%, which is nothing but the clearance ratio K. So clearance ratio K is equal to Vc by Vs is equal to 5 percentage, is also equal to 0.05, and the polytropic index given in the problem is n is equal to 1.3. And what are the things to be calculated? Stroke volume, volumetric efficiency, indicated power, and the final temperature of air. Solution. In this problem, the clearance volume is considered. So, volumetric efficiency is VA by Vs. When clearance is considered, this VA is nothing but V1 minus V4 divided by Vs. And how to find Vs? Vs into Nw is equal to V1 minus V4 by volumetric efficiency, because we are multiplying this Vs by Nw. The reason is V1 minus V4, the free air delivered, is given in terms of meter cube per minute. In order to balance the unit both sides, we multiply this Vs by Nw. Now we want to find what is Vs, so the Nw comes here, so we get N V1 minus V4 divided by volumetric efficiency into number of working strokes. Let us substitute the corresponding values, and finally we get the stroke volume is equal to 0.056 meter cube. And volumetric efficiency formula already we have seen, it is 1 plus k minus k into P2 by P1 power 1 by n, where k is clearance ratio, P2 delivery pressure, and P1 inlet pressure. When we substitute all the corresponding values, we get the volumetric efficiency as 82 percentage by multiplying 100 with the given value, with the value we got. Now we want to find the temperature of the outlet air. So we know the ratio between inlet and outlet in the case of polytropic process. So between the temperature and pressure, the relationship is T2 by T1 is equal to P2 by P1 power n minus 1 by n. So T2 is equal to T1 into P2 by P1 power n minus 1 by n. When we substitute all the values, we get T2 is equal to 449.9 Kelvin. Finally, the indicated power, the formula n by n minus 1 P1 into V1 minus V4 by 60 into P2 by P1 power n minus 1 by n minus 1. Here we divide this by 60. The reason is we want the unit in terms of kilowatts. So we know the pressure unit always in kilo Newton per meter squared or kilopascal, and V1 minus V4 is nothing but a free air delivered, which is given in the problem in terms of meter cube per minute. So this meter square gets cancelled, one more meter here, kilonewton meter, nothing but kilojoules per minute we get, but 1 kilowatt is equal to 1 kilojoules per second. So to convert this minute in terms of seconds only, we divide this by 60. So finally we get indicated power is equal to 57.51 kilowatts. So the results are displayed here. The stroke volume 0.05 meter cube, volumetric efficiency 82 percentage, outlet temperature 449.9 Kelvin, indicated power 57.51 kilowatt. And one more problem we are going to see in the same reciprocating air compressor, but this is multi-stage. But it is single acting. So Nw is equal to N, number of working strokes is equal to speed of the compressor, and inlet volume, inlet pressure, and inlet temperatures are given, speed of the compressor is given, and the delivery pressure, number of stages is 2, and here it is perfect intercooling. We know perfect intercooling means T1 is equal to T2. It means in the case of two-stage compressor, when we see this is the suction pressure and this is the delivery pressure, and this is going to be 2 dash and this is 2. This is low pressure compressor and this is high pressure compressor. In the case of PV diagram, between 2 dash and 2, intercooling takes place at constant pressure. When T1 is equal to T2, it means a perfect intercooling. It means the inlet temperature of the low pressure compressor and the inlet temperature of high pressure compressors are same. So T1 is equal to T2 given. So mechanical efficiency is 75%, volumetric efficiency given in the problem is 80%, average piston speed is 3 meters per second, and the polytropic index is 1.5. This is the given data. And the parameters to be found in this problem is minimum power required, diameter of the compressor cylinder, and the stroke length of the compressor. First, we are going to find the minimum power required to run the compressor. So we know the formula to find the indicated power is equal to xn by n minus 1 into P1 V1 Px plus 1 by P1 power n minus 1 by xn minus 1. This is for x number of stages. But in the given problem, it is 2 stage. So we are going to replace this x by 2. So we get the formula. Now let us substitute all the required values in the formula. We get indicated power is equal to 43.26 kilowatts. We know the mechanical efficiency is the ratio between indicated power and the shaft power. Therefore, shaft power is equal to indicated power divided by mechanical efficiency. Divided by mechanical efficiency. In the given problem, mechanical efficiency is given as 0.75. So we get shaft power is equal to 57.67 kilowatts. The average piston speed given in this problem is 3 meters per second, which is equal to 2ln. So we want to find out the stroke length. So L is equal to 3 divided by 2n, where n is the speed but which is given in RPM, revolutions per minute. We want in terms of RPS, so we divide this by 60. So finally we get the stroke length as 0.36 meter, which is nothing but 360 mm. Also we want to find out the diameter of the compressor cylinder. For that we are going to use a formula. Stroke volume is equal to pi d squared by 4 into L into Nw. To find the diameter of the compressor cylinder, stroke volume is to be calculated. For that we are going to use a formula. Volumetric efficiency is equal to VA by Vs. So Vs is equal to VA by volumetric efficiency, where VA is effective suction volume. In this problem, VA equal to V1 and the volumetric efficiency is here. So the values are given. So substitute the corresponding values. We get the stroke volume as 5 meter cube per minute. Now, by using this formula, we are going to find out what is D. So we can send the all other parameters that side. We get the diameter of the compressor cylinder is equal to square root of Vs into 4 divided by pi into L into Nw. Let us substitute all the corresponding values and we get D is equal to 0.265 meters, which is nothing but 265 mm. So from this we have calculated the minimum power required is 57.67 kilowatts, stroke length 360 mm, and diameter of the compressor cylinder 265 mm. Thank you.